we'll go forward for our next lecture. Dr. Oznur Karaca, she is Associate Professor Geological Engineering, Kanakkale Onsekic Mart University, Kanakkale, Turkey. Okay, sorry, I am that if I am not able to pronounce it, Dr. Oznur, how you pronounce it? It's okay?
Yeah.
Okay. So now the talk of the title is environmental issues related to mining, problems with mining sites, characterization and remediation options. So before I request Dr. Oznur to start, let me introduce her. Dr. Oznur Karaca, Associate Professor of Geological Engineering, received her PhD in Geological Engineering Department from Süleyman Demirel University, Turkey. She has been at the University of Illinois, Chicago in the Department of Civil and Material Engineering, USA for 1 year as a visiting professor. Her research areas include engineering geology, geotechnical and geoenvironmental engineering, remediation of contaminated soils, sediments and mining wastes, GIS and remote sensing. So far, she has published 16 journal papers, 1 book chapters and 39 conference papers. So now I'll request Dr. Oznur to start his presentation.
Thank you, Professor Das, for this kind introduction. And also I would like to thank the organizers for this well-thought and well-organized online course series and for giving me the opportunity to be here with you. Of course, it's not the same as to be face-to-face, but this is also an opportunity to be all together in this environment and share our knowledge here. It's good, thank you again. And also before starting, I thank the previous nice presentations. I'm the last one, and before me, there were many good speakers and nice presentations here, and I learned very much from them. Can I share my
Yes. Yeah, you can share, please.
My presentation is about environmental issues related to mining activities and their problems, also the characterizations of the materials in mine sites and their remediation options. In this concept, I'm going to talk about the problems with mining sites, problems of mine tailing disposal sites. I will give some examples. We did some study from Turkey, and also I'm going to talk about the remediation possibilities. We know that mining is the extraction of minerals and geological materials of economic value from deposits on the earth. Actually, mining industries provide us the materials to build infrastructure and instruments of daily use, such as obtaining large amounts of energy. So we need them. We need coal, we need gold, we need silver, lead, copper. But the problem is improper mining activities and after. Here, how can I do this? Sometimes I cannot see a whole presentation from this. Maybe I shouldn't use this. Okay. Environmental impacts of mining are mine waste because they are the source of heavy metals and acid mine drainage. They affect the biodiversity, amenity, and economic wealth. Sorry, I interrupt, but I think I should take all these here, but here I cannot see it myself. How do you do this? I cannot see all my presentation, and I think it's fine. Sorry for the interruption. So they affect the biodiversity, amenity, and economic wealth. Here, to determine the physical-chemical characteristics, the expected metal concentrations in leaching effluent is important rather than the actual total metal concentrations. Also, to define the pH, grain size, mineralogy, chemical composition, and heavy metal speciation is important. Otherwise, we maybe encounter unacceptable risk to natural life and human health. Environmental impacts are mostly influenced by geological factors. For example, lithology and rock alteration are the source of contamination. Natural rocks, we know they include minerals, and when we excavate them, rocks break into small pieces, and some minerals can have a detrimental effect when exposed to air, and we will talk about this also. Topography and hydrology are the other effects spreading the contaminants, because drainage systems can transport polluting materials to other basins. And mining and milling methods are also important. For example, open mining activities have much more detrimental effects. If we talk about the mine tailing disposal sites, coal is here, and to reach the coal, we need to excavate and take all these layers. Problem starts here. Related to this excavation, we lose forest and we encounter with different pollution due to mining, formation of sinkholes and land subsidence. Noise and vibration are another problems. They have impact on water, biodiversity, landscape, wildlife, soil quality. And similar to these, mine tailings also have negative effects on environment, such as dust, dam safety, and here also during this course, speakers talk about the dam safety, and weathering is the problem, water and groundwater quality, of course, soil erosion, heavy metal pollution, and maybe one of the most important problem is the acid mine drainage. I will give some examples from the world. Here, this picture from Indonesia. They cause huge damage to the landscape we see here. And we said that mines affect the water, and due to the low quality of water, fish or other living things die. And this is the aerial view from strip mining near the Ohio River, and they discharge wastewater to the river. And we said that acid mine drainage is maybe the most important problem related to the mining activities and mine tailings. So what is acid mine drainage? It is basically polluted water discharged from abandoned mines. Metal sulfides, when exposed to air and water, react to form a sulfuric acid solution containing dissolved metals. This mixture is known as acid mine drainage, or AMD. The majority of acidic sites worldwide have their origin in, unfortunately, human activity. Acid mine drainage or acid rock drainage refers to the outflow water from metal mines or coal mines. And this phenomenon is connected with the bioxidation of pyrite or other sulfide minerals. When mineral deposits containing sulfides are mined, they have the potential to produce acid drainage, and it is caused by the physical and chemical weathering of the common mineral pyrite. And this photo is from an abandoned mining site from Çanakkale, from Mine City, and after the precipitation comes to the pits, is exposed to the sulfide mineralization in the pits and or in the underground workings, and forms the acidic drainage. And we have like this acidic lake here. We have two concepts. One is the acid mine drainage. This one is water that is polluted from contact with mining activity. And if it is natural rock drainage that is acidic, and we call this acid rock drainage, and both produce acidic waters. And we said that, again, I cannot see the whole. We said that if we have sulfide mineral, and commonly we have pyrite, and when they expose with water and air, the result is low pH and metals. If you look at the formation mechanism of the acid mine drainage, and simply we said that in the previous slide, if we have sulfide minerals and we have oxygen and water, and the result is here sulfuric acid and dissolved metals. And the pH or AMD can be less than 3. We did this one also from here, from Çanakkale. And acid drainage solubilizes and mobilizes some heavy metals such as arsenic, manganese, copper, lead, and streams are often devoid of life. If you look at the characteristics of AMD, they have low pH and they have increased metal concentrations or increased sulfide and or increased suspended soils. Of course, all four don't necessarily occur at the same time. Of course, this unfavorable environment affects the aquatic life, and their effects are direct physical damage to skin, gills, eyes, challenge to maintenance or internal pH, or increase in metal concentrations. Of course, here we have some problems related to mining activities and mine tailings. Here we see the biggest open pit mining in Çanakkale, of course not in Turkey, in Çanakkale, the biggest one here. This one also ongoing mining. Our problem generally mostly the small companies. Small companies are coming to the site, take the mine and put the waste here, then abandon the site. After that, as we said before, after the precipitation, we have acidic lakes here and pH are very low. Another problem is tailings. Again, I will interrupt, but because of the this here, I think you see my screen. I cannot see whole presentation. How can I solve this? Hello. Dr. Light Kumar.
Yes, Satyam, are you there?
Yeah. Because of this, I cannot see whole presentation. How can I?
Just unshare your screen and share again and put your slide on slideshow mode. Then maybe
just slides. Oh, okay. Okay. Sorry for the interrupt.
It's clearly visible for us, but
yeah, but I cannot see the more.
Just go for the unshare. You can stop sharing.
Or just share this.
Yeah, before that, you just go for a stop sharing.
Stop share. Okay. 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 Then this one. So it's again saying.
You can share your screen, means your PPT screen.
Stop sharing. I said share screen. I share only this.
Yeah, you share your PPT. You keep your PPT open in the window.
Is it okay?
Yeah, it's appearing.
No. Yeah, it's fine. Huh? Okay, you can see, huh?
Yeah, it's appear. Yeah.
Okay.
So
Another problem is,
so now you can read by yourself.
no, I cannot. No, I cannot read.
I think, Dr. Oznur, the problem with your low bandwidth.
What? Sorry?
Yeah, maybe low internet bandwidth is low. That's what it is showing. So maybe that's why you are not able to see your screen.
No, not a whole screen, actually. It's fine. I will do like this. Okay, we'll continue. Sorry, if you see, I will also check another. Okay. Now, okay. And another problem in Çanakkale, we have tailing problem and of course water erosion, and also health problem we have here because people use this water. Of course, it's not the same lake as I showed you in previous slides. These are not acidic like that much, but it has it includes heavy metals. Also, we have dust pollution and air pollution. And we have landscape problem also. This is just an example. This is just an example from the numerous cars or open cut coal mines in Turkey. And I do like this. There are different kinds of mining activities in Turkey. These are open or underground mining for various types of ores. And as I said before, generally companies are coming to the site and open the pit, operate, take the mine and abandon the area, and the results left to us, mine waste, mine lakes, different kinds of pollution and loss of risk. So what should we do? We need to define clearly the boundaries of the relationship between environmental health, mining, and mineral processing, and study much more deeply. And also, we should determine the geochemical interactions at tailing sites and wastewater courses and effects on agriculture. So to protect the environment and living things, the key point is prevention and remediation. Of course, prevention is what we really want here because remediation is more expensive and time consuming than the prevention. There are various types of remediation technologies, such as soil washing and soil flushing, stabilization and solidification, SS techniques, and vitrification, electrokinetics, phytotechnologies. I will give 2 case studies from Turkey. We did with Professor Reddy from UIC and with Professor Camasella from Spain, from Vigo University. In these projects, our study objectives were to investigate the characteristics of the mine sites. For this purpose, we determined the physical and chemical characteristics of the mine tailings and lake sediments, and also we determined the heavy metal content. And we determined the environmental impacts. For this purpose, we did some leachability tests and to understand the bioavailability and heavy metal speciations. I said there are many types of remediation options, but those, especially conventional methods, are expensive, more expensive, and also maybe more harmful to environment. Because of that, we investigated the capability of electrokinetic remediation and also phytoremediation. Our study area is located in the northwest of Turkey, in Biga Peninsula, in Çanakkale. Maybe most of you know here as Troya from the movie. And this is our first project area. These are the acidic lakes from that side, and these are our sample locations. And this is Çam Basin. And Çanakkale Bayraminç Neogen Basin has lignite beds, and these lignite beds are rich with inorganic materials such as arsenic, and this is another acidic lake and underlying sediments here. And in this project, we determined the physical parameters of sediments, tailings, and rocks. Also, we determined the metal contaminations. Most abundant metals were lead, cadmium, nickel, barium, iron. The day before, I think Professor already also said for iron there is no standard, but iron is important for the acid mine drainage, etc. It's metal. So we investigated this one also, and arsenic for the two samples. We determined the chemical properties. For this, we defined organic content, pH, ORP, and electrical conductivity. To understand the leachability and bioavailability, we performed the batch and column tests. For the column test, we used small column and DI water. And we found that soils and lakes at the site have high acidity and high electrical conductivity values. And lead, chromium, barium was higher than the standards. Also, arsenic values in two samples higher than the standard. Leachability of sediments and tailings, of course, more than the rocks. And iron content in soils was very high, and it comes from pyrite. Overall, this study showed that acidic conditions existed in these samples, as well as effluents, and relatively high amounts of leachable heavy metals were found. Based on these results, we need to define appropriate remediation technique for the site. And this is our second project area. Here, the previous old mining area, and this is the new mining area. If you take the cross section from north to south, we can see the field easily like this. Here, the old mining area and new mining area. As I told you, companies are coming here. They took the coal and put the waste here, then leave the sites doing nothing. And after the precipitation, of course, obvious result is acidic lake here. And here also they are doing the same thing. In this project also we characterize the sediments and tailings. And similar results we had. For example, pH values were very low, and also electrical conductivity values were very high. Our metals were lead, iron is very high, arsenic, and barium, aluminum also were very high. But we studied only lead and iron in that project. And again, to understand the leachability, bioavailability, and the metal speciation, we did column experiments. And this project, we did also TCLP and SPLP method. Also, we performed the sequential extraction analysis based on the TCR et al. 79. After the column test, we see the results here. Mine tailing released much more metals. We can see from here much more metals than the sediment. And iron was easier to release than lead. And similar concentrations was found for lead and iron in the sediment. I'm using two computer and I'm looking at there also. And for the metal concentrations leached from mine tailings, we performed the TCLP and SPLP method. When we look at the results, iron leached at higher concentrations than lead in both tests, but this is because of the much higher concentrations of higher iron than of lead. But the fraction of lead extracted is much more important than the iron. The extraction of lead is similar for both mine tailing and sediment, but the TCLP method tends to extract higher concentrations than SPLP. And as a result, both samples are considered hazardous for the environment. We also performed the sequential extraction analysis before and after treatment. Here we see the before the test results before the treatment. As we see here, lead was evenly distributed in 4 fractions, but iron was mainly concentrated in the fraction 3 and 4 for both materials, mine tailings and sediments. Based on the results, the environmental risk of the mine tailings and lake sediments in Çanakkale mainly due to 2 factors. One is the continuous release of heavy metals to water in contact with sediments and tailings. And the second one is the acid pH in lakes and leaching effluent from mine tailings. Of course, in these conditions, wildlife is not sustainable in lakes or soils. Here we can see the risk easily from this satellite image. This is the mining area. It's very close to residential area. And it's very dangerous for humans and also animals. Of course, for the remediation option, we cannot say that this remediation is good for each area because the remediation efficiency largely depends on site and contaminants characteristics. So each project area, we need to determine the remediation method for those for that area. And conventional technologies tend to be very expensive due to high energy consumption and also maybe more harmful than the modern techniques because we can use more chemicals to remediate this site. Because of this, it limits their applications to relatively small contaminated sites. For that, when we think about the large contaminated areas like Çanakkale, these physicochemical technologies are impractical and economically unfeasible. And among those various remediation possibilities, we focused on two remediation techniques, and one is electrokinetic remediation. For this, we used both material, both samples and my tailings. We conducted the test for 9 days. We applied the electric current 1 volt direct current per centimeter. After the application of an electric field to the specimens, favored the formation of an electro-osmotic flow towards the cathode for both material, but the tests with mine tailings show a constant E-off toward the cathode. Also, we determined the soil characteristics after the treatment. Here. After the treatment, sediment was slightly acidified in the first section due to the penetration of the acid front from the anode. Mine tailings didn't show any significant pH change, and ORP in the mine tailings was uniform, but sediment showed a negative ORP in the cathode side, probably due to the alkaline environment. EC values, electrical conductivity values decreased after the treatment due to the removal of ions. When we look at the heavy metal concentrations in the sediment and mine tailings after the treatment, again, the removal of lead was more effective in the mine tailings than in the sediment. As we see here, the residual lead concentrations increased from section 1 to section 4. As I said before, we performed the sequential extraction analysis before and after the test. Here we see the initial concentrations here, sequential extraction results here. And we see here metal distribution in 5 fractions of the sequential extractions before and after the test. And the most labile fractions of label are dissolved in the first section of sediment and also mine tailings. Lead is transported towards the cathode. Thus, in section 1, lead fractions from 1 to 4 decreased compared to the initial analysis. The transported lead toward the cathode was accumulated in the other sections from section 2, 3, 4. And as I said, we focused on 2 remediation methods. One was electrokinetic remediation, and the other one is the phytoremediation, and we can say also phytocapping. Phytocapping is cost-effective, low maintenance, environmentally friendly, reduces wind and water erosion, prevents the contact and oxidation of the solid materials with atmospheric oxygen. And here on Tuesday, there was a question about the treatment of acid mine drainage. maybe this one can be one of the answer to treat the acid mine drainage, because we prevent the metals from the oxygen and air and also water. And here we see the mechanism and the classification of the phytoremediation. In phytoremediation, contaminants can be stabilized near the root area, or root can take the contaminants. These contaminants can be also organic or inorganic contaminants like heavy metals, or the contaminants can accumulate in leaves or stem area. Then we can classify according to these properties. For example, if the contaminants stabilize here near the root area, we say phytostabilization, or if the root take the contaminants, rhizofiltration, or accumulated in the leaves, we say phytoextraction. In our project, also we tried two kinds of plants. One is oat plant and another is sunflower. And of course, our first trial was failed because, you know, our both mine tailings and sediment specimens were very acidic. pH were 2 and 2.3, like that. Because of that, all first they start to germinate, and after that they all died. And after that we amended with lime, and after that they survived, germinated, and grew. After 3 months we harvested them. I hope the remediation results will be used in the design of practical and sustainable remediation process. Here I will give some example from success stories around the world. This one is from Turkey. This is from the gold mining area. These are not the natural hills. Actually, these are mine tailings. Their disposal site here. But after they disposed, and then they planted olive trees here, and they succeeded. And another example is from Newcastle, England. While mining activities were continuing, extra land close to the mine was transformed into large public area. So if you want, we can do nice things. So in this study, we learned that we need to characterize the mine sites. For this, we should define the physical and chemical properties and also metal content in the material. Then we should investigate the environmental impacts. For this, we can do leachability tests. After that, we can decide the remediation methods, because as I said before, we cannot say this remediation technique you can use for every area, but every area is specific. So first we should learn the characterization, then the environmental effect, and after that we will choose the appropriate remediation techniques. Due to the mining activities, nature had been damaged in broad areas, and these areas generally become barren. The environmental effects of mine waste are not just due to the heavy metal contamination. At the same time, wind and water erosion and slope stability are problems. And in Çanakkale, our problem is acidic conditions. Acidic conditions allow the release of metals in solid materials. As a result of these negative effects, the remediation of these areas is unavoidable. In this situation, among many remediation methods, phytokeeping and electrokinetic remediation come to the fore. Thank you.
Thank you.
Thank
you, Dr. Oznur.
Thank you, Professor Dan. If we have time, as I said during the presentation, someone asked about the treatment of acid mine drainage. Actually, I'm not specialized for that, but while I'm talking about the phytoremediation, we can use that. Also, I found something I can mention about that. Maybe today also someone can ask that question.
Yeah, that question was there. So I will be also, I mean, it will be better if you can elaborate in phytoremediation.
Sorry?
I mean, it will be good that if you can elaborate on this phytoremediation, because you show some picture on the phytoremediation in Turkey, then one in UK.
Yes.
So this is, can you tell on phytoremediation or acid mine drainage?
These are. This is
this one, not the previous one, also previous one. Yeah, this one.
This one.
Yeah.
Actually, rehabilitation. We can say rehabilitation, but to say, I think phytoremediation, we should study on it, because of these trees, after these trees planted, maybe they stabilize the contaminants and they don't go through the groundwater, but we should study that one.
Okay. So can I mean, there are some queries.
Can I also now?
Yeah. So now, can you take the questions right now?
So are you comfortable to take up the questionnaires?
Can I also read them?
Yeah, could you please take up the questions?
Okay, participants, chats. I cannot see the chats here.
Okay, I'll tell it.
We can read for you.
So like one from Pratik Goel. So his question is, what are the major challenges faced by site engineers due to acid mine drainage?
What is the main challenge?
Faced by site engineers, the professional engineers, due to acid mine drainage.
So I think I couldn't understand here.
I mean, when I said that you show some pictures of acid mine drainage, can you go to that slide, please?
Yes.
Can you go to that slide where you said acid? Yeah, this acidic lake. Yeah, this one.
Yeah.
So
here I think
some more is also there. Yeah. So what are the problems associated with this acid mine drainage?
What are the problems? The main problem is the acidic, because it's acidic, and I have some pictures, but I didn't put here. Actually, from here, they go to surface water, and also they can go into the groundwater. Then we use them. And also I showed some pictures people use for, I don't know, maybe irrigation. And I didn't tell here, but one cow dropped into the lake and died. And it could be human also, both animals, and here also we see the effects. And also plants, they don't grow plants. This is new. Because of that, I think still there are plants here.
Okay, so now suppose Okay. So suppose now an engineer wants to go at the site, on this site. As an engineer, you will go and work in this site. So what are the problems you will face? How you will work with this environment?
What are the problems?
How you will work in this high acidic environment? So what is workplace safety? I mean workplace safety while working on this acid mine drainage.
Now I saw, I read phyto remediation is which minerals, which one?
So that is the part in that query we will see too long before it was there. Like the query was at 11:45 from, oh sorry, AM, I mean IST time. So your time may be around 8:30 or 8:45. What are the major challenges faced by site engineers due to acid mine drainage? So I want to.
What are the major challenges faced by?
Yes, yes.
Yeah, yeah. It's main problem in the area actually. Acid mine drainage. You mean the how to treat the acid mine drainage? The question is this.
Yes.
Yeah, as I said, actually, I'm not specialized with the acid mine drainage, actually, but we can do first, of course, we need to discharge this one. Also, miners are coming here. For example, they discharge to surface water, and sometimes they decide to use this area again, and they come to the area and they again discharge this water, and they continue to take the mine here. But they are doing this before taking cautions. Can I say that?
Okay.
Yeah, but we need to discharge, of course, by taking some cautions, and after that, we need to treat that area. I'm not sure if I could answer this question.
Yeah, it's okay. It's okay. So now the next question is on electrokinetic remediation. Electrokinetic remediation.
Do you plan to use electrokinetic in minefield? Yeah, we are thinking to that. Actually, we start another project, but it's not related to heavy metals. Actually, we are working on saline soils. Before we did saline soils, similar EK sand, but now we are doing not exactly in the field, but before field, we have a big container, and we are trying there because the here electrokinetic remediation for us, the problem is the electrodes, because our electrodes are having corrosion. Because of the corrosion, the electrodes are finishing.
Okay. Yeah, that's a very good point. Corrosion is a major issue because pH is so low.
But for this area, I think electrokinetic remediation is not good because the area is very big and tailings are very, because electrokinetic is suitable for the finer material like sand, silt, clay, like that, but tailings are coarse-grained materials.
Okay.
I think the best option is phytoremediation in this area.
Okay. So next question, can you go through the next question?
Was there any specific plantation configuration followed on the slopes to prevent erosion? For me, no, but I know one plant they use here, but I know only a Turkish name. Maybe
Okay.
I can check. I can check from the internet. I'll tell you later. Okay, thank you. It's really wonderful. Thank you. Are the plants used in phytoremediation not harmful for consumption? Sorry. Plants used in phytoremediation not harmful for consumption?
Yeah, I mean, I'll try to say that. Suppose you say about the pines. Sorry, right? So what you said, you are growing some plants. If that food through phytoremediation, through leachate, it can reach the fruits. So whether the people can take that fruits.
Ah, yes, exactly. We thought the same thing. They planted olive trees there. Actually, before studying, people shouldn't eat them. I'm worried about that also, of course.
Yes.
Because if you use those plants, for example, I said sunflower and oat plant we tried, and if you use those plants for this job work, and you shouldn't use them, of course. You need the harvest, and after that, there are some factories, they also take metals from the plants. Also, if the plants are accumulating plants, if they accumulate the heavy metals to the leaves, they take the metals from the leaves and they use that. Then after they buried the plant. You don't consume, you don't eat those plants.
Yes. So I'll request, can you go for the next? That is a very good question from Dimitris.
Example. Dimitri. Hello, Dimitri.
Yeah.
Which minerals usually comprise mine tailings? Pyrites. Here is the coal mine. Generally, we see pyrites. Can they change their surface charge from negative to positive? Actually, I didn't work on it in very high acidic medium. Possible, and thus provide inverse electroosmotic. Yeah, about the electroosmotic flow, yes, but I didn't work on the surface charge. You know, here about the projects, we have some problems, money issues. We want to, of course, work everything, but it's difficult to study everything. For example, I said we had several metals in it, but we had to choose 2 of them. Here also same. I didn't work on it, but electroosmotic flow, because metals don't move just only the electroosmotic flow, also like electromigration, because of the like ions and anions can go different sides.
Okay. So Dimitris, I really appreciate your effort. So yesterday also, actually, hope this question was there.
I know Dimitri. Yes,
Yeah. So yesterday also he asked this question to Greg Smith, and because particularly he is more interested to know about this
you
inverse.
can maybe talk about this with Professor Kamaseye. You can write it. I will ask.
Yeah, right now I'm requesting he can send a mail, personal mail to him. Yeah. You can go for the next.
Which one of the shake extraction, TCRP, SPARC is the best test for heavy metals assessment in mine tailings and also for solidified mine tailings. For us, SPLP method, TCLP method we found is better.
Which one? TCLP is better?
TCLP.
Okay, okay.
Phytoremediation is a good method to remediate contaminated mining. Because of the, I think, internet connection, I hope my voice was good to you, but sometimes I cannot hear exactly all the words.
Yeah. Okay. Yeah, better. You go through that, better.
And also my English is not good.
No, that's not an issue.
Yeah, it's the issue. Contaminated mining, sorry, phytoremediation is a good method to remember. But what if the contamination be present beyond rhizosphere? How the roots of the plants can be able to absorb? Actually, you choose, if I understood correctly, actually you choose the plants according to the contaminants. For example, our aim was the stabilization, not take the accumulate the contaminants to leaves or stem area. We aimed to stabilize the contamination to prevent from the contamination to go to other basins and groundwater. So you will choose the plants according to the contaminants.
Okay.
Generally, I hope it's okay.
Yeah, it's
Generally,
okay.
in large catchment, areas like this, how can we tackle piping? Generally, in large catchment areas like this, how can we tackle? I don't know this.
Yeah, that's okay, because this is related to something else. That is strength and other part of this a piping problem, and I mean that is loss of strength of the and other things. Can you go for the next?
Use the waste materials, and also the chemistry is important here. Actually, I'm a geological engineer, and I was studying on geotechnical engineering, geotechnics. And after we met with Professor Reddy, we started to study this subject. And thanks to Claudio, Professor Comasegna, because the chemistry is very important in the subject.
Yeah, yesterday he was there. I think today he has not there. Claudio was there throughout the last 3 days. He was here. He was in the audience.
Yeah, he said maybe he can attend, but for them it's earlier.
Yeah, too early for him. Now it is too early for him.
2 hours. Here I have an Indian clock. 2 years ago, we were there in Delhi and they gave us a clock, and still I didn't change the time. Still I'm using the Indian time here.
Thank you.
Can we use waste materials for the treatment of AMD for any other suitable methods? So, if the material is suitable, for example, fly ash, maybe you can use to treat the AMD also, because of the their chemical. Yeah, you can use fly ash to remediate the AMD or maybe other waste materials. The food chain effect, of course, the food chain effect very much, because here also, for example, here in this picture, if it's too long, they take the metal, if they take, not stabilize, if they take, and animals eat those plants, and after that, if we eat them, both plant or animal, of course we affect them. Yeah, food chain is very important. What is the reason for death of aquatic life in this slide shown by? Because of the quality of the water, pH is very low, and also metal concentrations are very high because of that. And also, for example, our plants also, we tried both plant and sunflower. First, after 1 week, they germinated, they all died. And actually, first, I did. Of course, we thought, but first we wanted to try, and after that, we amended with lime. Again, it was really difficult to increase the pH value with lime, and also I didn't say here, but we added biochar also, lime and biochar, and after that, they could germinate and grow. Thank you for your, thank you.
Thank you.
Dimitri, again, thank you.
Thank you, Dr. Oznur. So we have come to the conclusion of your talk, but I'll request you if we can stay for a few minutes. We'll go for our closing session.
Okay.
Okay.
Thank you. It was really a nice course. Yeah, really. Thank you.
Thank you. So I'll again request for your feedback. Please be on the line now. I'll request Dr. Lohit Kumar